We're here to talk about the Ratpack Web Framework and what it is, and some basic overviews, some technical deep dives, some conceptual discussion, et cetera, et cetera. It should be very good. Just by a show of hands, is anyone here using Ratpack today? Or have you played with it? Cool, cool, that's good. So like 5 or 6 people, that's really great. How many people have heard of it besides this? Cool, so some of the people that are using it have never heard of it. Which is great, but it's almost the entire room. That's pretty cool. It's come a long way since I joined the team about a year ago, in large part to my contributions, thankfully. Since I joined the team, yeah. Just joining the team, I feel like brought us to a new level. So who am I, anyway? My name's Dan Woods. I write articles for InfoQ sometimes about Java technologies, JVM, space, enterprise Java, all of that kind of stuff. If you guys are interested in the JVM and you enjoy writing, it's a really great way to get some of your thoughts and ideas out there. For me, more important than anything, it was a really great opportunity to get connected to all the new stuff that was coming out. And I enjoy learning about all that new stuff. If you guys are interested at all, definitely reach out to me. I'll get you connected with the right people. My code from today's talk, all my other talks, past, present, future, are on my GitHub, github.com/dandeveloper. You can find all my extremely well-tested open source projects on there, and very well documented and mostly abandoned. Probably everyone already follows me on Twitter. If you don't, I don't know what you're doing. You follow me. Unfollow, okay. That's enough. At dandeveloper on Twitter. Definitely, probably the easiest place to reach me, honestly. But if you don't follow me for some strange reason, you can reach out to me directly through email, danielpwoods@gmail.com. Feel free to email me about Ratpack or about basically anything. In my spare time, I write code for Netflix. So there's that. And feel free to reach out about anything Netflix related too. So quick overview of Ratpack and kind of what it is. I think that this is a very important part to the talk, because this kind of introduces you to what the modern idea is for Ratpack. So Ratpack was started several years ago, and it was inspired by Ruby's Sinatra framework. And Ruby's Sinatra framework is all about being a micro framework and effectively having a single Ruby file, a Ruby script that you can put all of your HTTP handlers into. You can define HTTP routes, and you have a very lightweight micro web application that you can get up and running in a very, very quick kind of way. That's a pretty popular and powerful concept, and especially with the emergence of micro frameworks, or microservices, micro frameworks like Sinatra are very pertinent. Like I said, Ratpack was inspired by that, but since being inspired by that, Ratpack has grown to be much, much more than just a micro framework. To the point that today we have support for full stack technologies, support like server-side templating, support for real-time data streaming with WebSockets and server-side events. We have pretty advanced and far along data binding capabilities in the framework that allow you to parse forms into Java objects that you can work with. Security, we have modules for Pack4J if you need authentication, and there's a module in the framework for session management. These are just some of the examples of the stuff that we've done to expand it out into being much more than just a micro framework. But we do still embrace that Sinatra legacy. So what the code that you're seeing on the right-hand side of the screen over here, this is a fully legit Ratpack application. This is all that it takes to get up and running. Basically, this is demonstrating the use of the Groovy DSL that we have in Ratpack, where you can define a route. In this case, it's just a simple get. It'll go to the default / and it'll render out a hello world, right? So this is all that you need to get started. And that's pretty cool. But it's an important thing to understand that above all else, Ratpack is not a Groovy web framework, right? So the core APIs in Ratpack are written in Java 7. for performance reasons, amongst all else. Soon they'll be entirely Java 8 standardized. We have first-class support for Groovy and Java 8, and that's possible today, and it's actually practical today, because Groovy has really come a long way. Hell, Groovy's come a long way in the last year, but considering the past couple of years that Groovy's had, is much, much further along. To the point that today where Groovy has static compilation and type checking and advanced support for documentation or hints like delegates too, that allows the compiler to know where you're sending closures and stuff like that. We're able to make use of all of this in Ratpack's core APIs, so that we can maintain a very performant footprint while still making use of the good parts of Groovy. So we're bringing in all the good stuff, and we're not bringing in any of the bad stuff. And that bad stuff is the stuff that gets you into trouble: code generation and meta object programming. We don't utilize any. I shouldn't say any. We don't utilize a lot of that. That's not the foundation for the Groovy support that we're looking to provide. So what we're looking for out of Groovy is being a very expressive DSL in a concise way, and that's more or less what we're getting. So Ratpack is built as a high-speed, non-blocking web framework. Performance is of paramount importance to what the framework does. The idea here is that we're aiming to bring you speed and throughput and efficiency of non-blocking programming strategies and non-blocking structure in a web application form. So that's great. A big part of the productivity aspect and of the Ratpack application's value is their ability to start up very quickly. So we're looking at application startup times in the milliseconds, which is fantastic. There's no container involved, so the overhead is very minimal. And that's something that we work to preserve and ensure that applications are going to continue to start up in a very quick way. Sometimes, depending on the requirements of your applications, you can get, and your hardware, you can get down to the tens of milliseconds, which is pretty cool. And in that same kind of effort, this idea that the developer experience should be extremely good is also a core tenet of the framework. We want it to be enjoyable and pleasurable to develop Ratpack applications, and it really is. So one of the things that we do to facilitate that is we provide development time hot reloading, so that any changes that you're making are reflected immediately. We do that through Spring Loaded. Spring Loaded was popularized, maybe that's a bold statement. Spring Loaded is used very heavily in Grails to provide that kind of that runtime swap out where you make a change and your changes are reflected immediately. But I think above all else, above all of this stuff, what I want you guys to take away from this talk is one simple thing, and that is that Ratpack is your gateway drug to non-blocking, right? Non-blocking is a very popular thing right now, and asynchronous processing. These are all popular things because we're looking for the most performant ways. We're looking for high speed. We're looking for throughput. This is what we're solving. This is the problem that Ratpack is solving. So understand that. And to solve that problem, we build on top of Netty. So Netty is first and foremost a TCP library, and Ratpack builds the focus on web and HTTP, which is just one aspect of what Netty is capable of doing. So Netty is a very powerful utility. We're making use of its ability to act as an HTTP server, but Netty is a foundation level abstraction because it's the most mature non-blocking TCP library that's out there. It also gives the fastest performance on commodity hardware. So we can run Netty on just about any machine and get throughput in the tens of thousands of requests per second, which is phenomenal. And it makes a lot of sense to leverage that, to leverage the work that's gone into that. The Netty team has done a fantastic job, and as an open source project, it's been wildly successful. So it makes sense. And a big part of that for us is that Netty is very thoroughly documented. And it has an excellent user guide, so we've adopted it wholesale. What we're intending to do with Netty, so basically Netty provides you with non-blocking asynchronous APIs for working with network calls, but without any kind of structure in that scenario. it's basically mayhem, and it's very difficult to build an application structure on top of something that's just strictly first and foremost a networking library. So what we want to do is we want to give that application structure, and we want to provide it in web terms, right, in a way that makes a lot of sense for you. Effectively, Ratpack's value proposition here is that it allows you to code a web application in a way that makes sense for you, in a way that you're familiar with, but still be able to garner the benefits that Netty provides. So what is the problem that we're actually solving here? There are some big problems with non-blocking asynchronous programming, and that's that the JVM has no continuations. So without that, we have to use asynchronous callbacks, right? And in order for APIs to wait for anything, we have to use asynchronous callbacks. Now just flat processing doesn't matter, but that's not realistic for any application, especially not a web application. So we need to use asynchronous callbacks. And this means that the original thread basically doesn't have any temporal relationship to the work of a callback taking a method. So when we're invoking a callback, that execution order isn't necessarily going to happen deterministically. So that non-determinism can basically put you in a situation where you have very unstable applications. You have to do a lot of work. You're stuck in callback hell. This is very much something that we don't want to see. So this is the basic structure of what a non-blocking asynchronous execution cycle might look like. In this example, you see the actual code in this doesn't matter too much, so don't think about that. But what I want to demonstrate to you here is that there are execution segments that are comprising this chunk of work. And what we see is that number one, we know number one is definitely going to happen first. However, number two could happen before or after 3 and 4. Number 3 could happen before or after 2 and 4. And number 4 could happen after 2 and 3, right? So this execution order is not something that we can guarantee at any point, right? And you as a developer are sort of left to design around the fact that the application can't be deterministic. So you have to build in your own serialization of asynchronous events through callbacks to achieve any kind of determinism. So that's a big problem. Our brains don't really think in this way. Computers think in this way, right? And computers are really good at doing this kind of stuff. But as developers, and actually just as human beings, without a lot of training, concurrency is extremely hard to understand and extremely hard to follow when you get into these non-deterministic execution cycles and trying to make those deterministic. So a goal of Ratpack is non-blocking made easy, right? We want to make that aspect something that you don't have to think about, right? So that you can get all of the benefits of non-blocking, but do it in a way that you can really easily wrap your brain around. So the framework is designed in a way that will bridge that gap. And to do that, Ratpack introduces something that is very close to JVM continuations, and that's in Ratpack's terminology is called an execution. Executions provide non-blocking synchronous programming, which allows you to design applications with deterministic processing, and this is the real value proposition for Ratpack. So Ratpack's a cool web framework. It's super fast. It does a lot of stuff, but serializing asynchronous and non-blocking executions is really what it's all about. So when we're building and we're writing web applications, those execution segments that we saw that were not wrapped in that chunk of work. So we're talking about here 1 and 4. Those are the execution segments. These other 2 parts. That's actual blocking work. Let's say that's happening between 2 and 3. So 1 and 4 right there. Those execution segments, they can be scheduled to. They come out of a request-taking thread pool. And while the work is going on for the processing and the blocking operation, we can return those threads to a request-taking thread pool. And then when the work is done inside of our blocking operations, then another thread, it doesn't have to be the originating thread, can pick up that chunk of work and continue the processing. And this gives us a theoretical high amount of scalability across systems that vary by the number of cores. But most importantly, it provides a deterministic execution path, and that looks something like this. So this takes the I guess the async out of the processing chain, but not really that much. All that we're really doing is serializing asynchronous events for you. So Ratpack's execution cycle is always guaranteed to run in this order, and we do that by guaranteeing that the execution threads that have called that have made the original call there are finished before any callback taking executions are started or invoked, right? So the determinism that we get there is that number one at the top starts, schedules this chunk of work, and then number two at the very bottom where number 4 used to be is then invoked, right? And then once that part finishes, then we'll go back to the other work, and we'll take that work and we'll schedule it off into a different thread pool, right? So let's say this is blocking operations. We don't want blocking operations to happen on our request taking thread pool, so we'll schedule that off into something else, and that allows the work effectively to happen in a way that we can guarantee every single time it's going to go this way. So from an application stability standpoint, this gives you the guarantee that you need for how your application is going to run. And this is accommodated through Ratpack's Promise API. Vertex provides a similar contract in its execution model. The synchronicity, however, is achieved in Vertex by binding an execution to a single thread, which from a performance standpoint makes a lot of sense. From a scalability standpoint, doesn't so much. But it turns out that in a lot of cases, the performance trumps scalability with modern hardware. But it's not necessarily a bad thing, right? So we can take and say that 1 and 2 are going to be achieved by working out of the netty request taken thread pool, because these are operating in the context of a request. Any other blocking operations, we know that we can schedule those off somewhere else. And then when we're ready, let's say in number 4 down here, that we're actually ready to write the response back to the client, then any thread from the request taken thread pool can resume that operation. So that's pretty cool. Another thing is that comparing here with Vertex, again, because Vertex is probably the closest web framework to match the kind of stuff that we're doing, Vertex's synchronous behavior is guaranteed only for its APIs. Ratpack's Promise API allows you to wrap your own calls that are not asynchronous APIs. So we can take any blocking operation. We can really take anything, and we can stuff it into a promise. It'll get scheduled onto some thread pool. Some execution will happen, and then your subscriber will be able to consume the result of that and write it back to the client. So this is a pretty big deal, right? Because you get all this for free. You don't have to think about it with Ratpack. And this kind of comes to this assertion here that I'm happy to make, and that's that Ratpack does blocking 100% right. And blocking is of paramount importance for any non-trivial application, right? It's great to be able to write an application and say it's 100% async, but if it doesn't do anything, it's totally pointless, right? In the real world, we have to make database calls, or we have to read from the file system, or we have to write to a message broker. Any kind of I/O constitutes a blocking operation, right? You're gathering resources, or you're writing out to a client, something like that. And in the process of doing that, the execution segments need to wait, right? So through Ratpack's Promise API, you get that kind of blocking that you need. And can guarantee you execution order, which is pretty important. So the execution context provides an injection into a blocking operation. So from within the context, we can, Ratpack internally manages the threads and the thread pools that it's capable of scheduling execution segments off onto. So within a handler, we're given the ability to supply a blocking operation, which returns a promise, and then we can subscribe to that blocking operation so that once it's completed, using the then, once it's completed, then we can render that back out to the client, right? So we can do all this work over here in an I/O thread pool or something like that, and then when we're done, we can go back to the request taken thread pool and say, hey, go and write this back to the client. That's pretty cool. And also with a promise, more of an not demonstrated here, but more of an abstract understanding of the way that promises work in Ratpack is that the execution is not started until they're subscribed to. So in this case, then is the subscription. That's where we're performing the actual act of subscribing. As soon as then is applied to the promise, that's when the execution actually starts. So operations won't happen without any subscribers, and that's probably a good thing. But it also allows you to chain operations together that you know need to be composed, right? Promises are composable, so that's a cool thing. Goal of the framework, don't try to be everything. That's a pretty important one. There are a lot of web frameworks trying to do a lot of stuff. And like I said, Ratpack is nowadays a full stack framework. But what I'm talking about is not so much don't try to do everything in terms of being able to build better and faster web applications, but more in terms of don't try to do everything for the developer, right? Y'all are pretty smart, and you guys know how your applications need to be structured. Convention over configuration is really great, and in a lot of cases, it takes the headache out of where do I put things, how do I name things, how do I figure it out? But there's magic there. There's always going to be magic there for convention over configuration to work. And taken too far, convention over configuration doesn't allow you to wire things together, right? So Ratpack makes that wiring process a one-liner. So we don't want to do it for you, but we want to make it really easy for you when you're ready to do it. So all of the wiring for putting components, for getting components into your application can be done through one-liner binding. And that allows us to support a very robust modular system. So Ratpack is able to be composed through modules, and we'll talk a little bit about what that means. Now, this also means that there's no plugins in Ratpack. So I was having a conversation at a meetup a little while ago with a guy, and he was asking me about Ratpack plugins, like when is the plugin ecosystem really going to take off? And I pointed out to him, Ratpack doesn't have any plugins. That's not really what it's all about. And he said, well, plugins, libraries, whatever, it's the same thing. But these are vastly different things. And I think that that's an important distinction to make. Ratpack will never have plugins because everything in Ratpack is a library. This is important because it means that the framework can be composed and logic can be reused in different contexts. So Ratpack's Promise API, for example, or Ratpack's Streaming API, for example, those are beneficial just in general. You can very easily extract a portion of the framework and use it in some standalone context or in a different context, and that makes it really. Absolutely. Yeah, exactly. So a more practical example of this is Ratpack's testing fixtures. They are part of the framework, but they're able to be used in a standalone context. So you can pull in just Ratpack's testing framework into a pre-existing application and make use of it, which is pretty cool. So the Ratpack's modularity solution, this idea that the framework is going to be composable means that it can scale in complexity. So as the complexity of the application grows, as we're adding more and newer features to it, we're able to scale, right? Because everything is brought in as a module. Things are not mounted on top of each other. They're composed gracefully and beautifully, I might add. There's no auto wiring getting in the way. Everything is written very explicitly. We don't want to get in the developer's way, right? Everything that you do is 100% under your control. You know exactly where things are coming from. It's not guesswork, I hope. And that allows, like I said, things to be decoupled when it's appropriate, or even fully retired when it's appropriate. Another goal of the framework is documentation, and documentation is a very I would say it's very far along in Ratpack. Not the user manual so much, not some of the other external documentation, but from within the code, we use documentation annotations like @nullable and @non-blocking to let you know very quickly what a method's behavior is going to be, right? So if you see a method that's annotated with nullable, you can pretty well assume that a null value is capable of coming back out of that method. And that helps you, right? That helps you a lot start to design your APIs or your consuming methods in a much better way. Another really, really cool thing that we do, and this is 100% Luke Daly's design and invention, is testing the Java docs. So when you're looking at the Java docs on the public APIs, they all come with examples of how to use the code, of how to use that particular method. And all of those examples are always going to be up to date because as part of the build of the framework, we extract those and then we unit test them. So they're all self-contained and able to be run on their own based off of the current APIs. And you know, anytime that you're looking at a Java doc on a public API in Ratpack, that's 100% guaranteed that that's going to work. So that's a pretty cool thing. Examples will never go out of sync. So that's the basic idea of Ratpack. That's kind of the higher level stuff, the stuff that makes up what is Ratpack and the ideas behind it. So let's deep dive into it. Let's talk about how do we start building applications with Ratpack. And probably the simplest and easiest way to get up and running and to get going is what we demonstrated earlier, and that's through a Groovy script approach. And just grab, import the Ratpack Groovy module and building it out that way. This is an excellent approach for quick prototyping and simple local development. You can very quickly try things out, see if they work, if you like them. You can get an API lockdown before you move into code, before you move it to a more formal project. It's excellent if you just need to quickly fire up a slim and simple, very few line microservice. However, there's no support for packaging or tuning configuration. For that kind of stuff, you need to use a real project. But you can get a really long way from within the Groovy console, which is pretty cool. And I'll show you what that's all about. Okay, so I have, can everyone, nope, you definitely can't. Whoops. View larger, there we go. Can you guys all see this now? That's good. Okay, so we have a very simple application here, web application. We have grabbed examples a little out of date. We're on 0.9.8 right now. But we've pulled down the Ratpack Groovy module using just the grab. We've imported aspects of it. We've created a handler chain. We'll talk a little bit about what handlers are, but using the Ratpack DSL, we can define handlers. And then, so this is a handler on the default route. And then what we're able to do with this is discriminate on the requested method using the by method syntax of the DSL. And say that for a post event, we want to parse out a form, and we'll get a form object, which is effectively it's part of the Ratpack API, where we can extract variables off of it. And in this case, we'll extract off a file that we'll upload to it, write that out to another file, and then we will send it back to the client, right? When we get a GET request, we'll render this embedded HTML, which is production-ready code, right? Because that's how I write all my HTML. So let's go ahead and fire this up. So you can see application startup times in the milliseconds is no joke. It started extremely fast. So let's go to 50/50. And you can see from here, we have a simple form, which is exactly what we have embedded here, right? And if I choose a file, so I've chosen my file, and I'm going to submit it. And when I do, we're going to write it back to the client, right? So it's as simple as that. We're discriminating on the method type. We're saying we're getting a GET response. We're going to upload a file. We're going to post some data to it. We're going to extract a file off of the form that's posted to us. We're going to write it out to a temporary file, and then we're going to send that back. So that's pretty cool. Like I said, we can use this in a lot of different scenarios to get up and running. To get up and running very simply, right? So the Groovy script approach is definitely the easiest and fastest start, and that's in no small part a contribution or an attribute of both Groovy and of the Ratpack core APIs, being able to support that. So for a more complex application, we have proper support for HTTP verbs. So the handler chain is capable of handling not just get and post, but also delete, put, and somebody, I can't remember who, Bobby Warner, added patch support for us as well, which is pretty cool. So we're capable of using even APIs or HTTP verbs that nobody in the world uses. So thanks for that. We also have support for prefixed routes. So handlers can be grouped logically under a specific route. You can extract out path tokens, and we'll demonstrate all this. But you can define the route, and then you can use the path tokens to extract path variables, which is pretty cool. And you can use request.query parameters or query params, sorry, to get the query parameters that came off of the request. We can serve static content. There's a lot of stuff we can do. It's probably better to just show you. All right. So inside of our thing here, we have prefixed routes. We can handle the different request types that are coming in, the different HTTP verbs, by using their semantic naming from within the DSL. So these are the handlers for the specific types, and this is defining that we want to bind a handler to a specific verb. We can attribute path tokens to it, so we can say that any time that somebody makes a request to /photo/something, we'll go to a GET request, I should say. We'll go to this handler, and we'll have access to the name that came along as part of the request. And likewise, we have support for alternative HTTP verbs like delete, right? So we can use these in different contexts. Additionally, we have the capabilities for doing things like server-side rendering, like I said. So in this example, I have a Groovy template that I want to render back to the client, and this is just using Groovy's what is it called? String. Sorry. Well, yeah, it is string interpolation. Script engine, Groovy script engine, right? To render this this photo.html, right? So we'll be able to do replacements, right? Like you'd be able to do inside of a GSP or something very similar. So going back to this, if I fire this up, let me double check. Yep. Okay. Yes. So now we've gone from that state of a very simple application where we're prototyping and we're embedding HTML to now we have a legitimate project structure here, right? And you can see this more or less kind of fits the Gradle / Maven kind of project structure. You can put your dependencies in source main Groovy. These can be your application dependencies. Ratpack also exposes a different source set route inside of source Ratpack. This is where you would put your ratpack.groovy, which will be the actual script that you prototyped out before. You move it into there, and you can have access to the whole project, right? So we fired it up. We're running on port 5050, and now if we go back, you can see nothing's changed, right? Because all that we've done here is put the form into, all that we've done here is put the form into HTML, and we're serving that up, right? So one of the handler types that Ratpack exposes for us is this asset handler, and we can tell it that a directory inside of that source Ratpack part of our project is going to serve up static content. So if none of the things matched, right? We didn't match on photo here. We didn't do any of this stuff that fell inside of photo. We didn't match on show/name, anything like that. So we've fallen back to the asset handler. And the asset handler can be kind of a catch-all. It's where you serve your static content. And what directory it is somewhat arbitrary. Different prefixes can also have different handlers, asset handlers. So it's pretty cool. So we're serving that index.html. You can see it's not much different. Everything is basically kind of the same. And what we're going to do out of this is we're going to post to /photo, right? So that's what we see. Our form action is going to go to /photo. We have our file attached to it there. And when we do that, we're going to parse the form again. We're going to delegate off to the photo service, and we're going to tell it to save this uploaded photo. So the API for photo service takes a uploaded file, which is part of the Ratpack form API, and it returns us a string. And what the Java docs say is returns the file name, right? So then we're going to, once we have that done, we're going to redirect to /show/name. Can anyone see something that I've done a little naively here? In this area? So one of the things that we talked about earlier is any kind of blocking operation, any kind of reading and writing constitutes blocking. And we don't want to do that in a request-taking thread. So in this case, saving a photo is going to constitute I/O, right? Because we need to write that out somewhere. So it's a little naive to say, OK, I'm just going to trust this, especially when this doesn't say that it's a non-blocking method. If we had used the documentation annotations, we would be able to say this is a non-blocking method that's happening. I happen to know that it's going to be non-blocking because I'm using the files NIO APIs to ensure that it's non-blocking. But there's no guarantee on that, right? Because this is an interface that could be implemented any number of ways. So a more responsible thing to do would be exactly what we're doing here in the delete handler, which is to actually perform a blocking operation using Ratpack's blocking API. Totally tangential. I was just curious if anyone would pick that up. So I got my thing, right? And this is cool. So we're gonna forward over to /show/name. That's gonna render our photo.html for us. Photo.html is going to include an image tag with the name, and go make a GET. This, of course, the browser will make a GET request to /photo/ whatever the file name is, and that is going to come in here. We're going to send the file using photoservice.get. Another example, we probably should have made this a blocking operation, but no big deal because I already made it NIO, so I'm kind of content with that. But yeah, we'll send the file back, and that'll get embedded into this page, right? And then this now, of course, is a server-side template. We can decorate it with some JavaScript and stuff like that, which is what we're doing. So I take that same file, submit it, and here we go. So now we actually have kind of a more complex web application that's able to do many more things. If I click delete, it'll go off to the delete handler. I'll set a breakpoint here. I'll prove it to you guys. So it'll actually come into here. These will get scheduled onto an IO thread pool. And you can see, of course, it happened. We got the name appropriately. We got the name as we would expect it. We're able to extract those details off of the path tokens map that comes back as part of the context. And we'll go off and actually do the work. And it tells us it was deleted, right? And that was more or less our test within the JavaScript. If we get back 204, which is what we're hoping for, then we'll fire up an alert box. So that's pretty cool. So this photo service, like I said, this is bound to an interface, right? And within our application here, it's great practice to program to interfaces, of course, and we can swap out the implementations. Ratpack makes it super easy to do that, right? Like we were talking about earlier, we don't want to automatically do this stuff for you because we want you to be able to choose what the right thing to do is. But we want to make it a one-liner when you're ready to do it. So from within Ratpack, you can make use of the bindings block here. And what this bindings block lets you do is supply that one-liner. So what we're saying here is that we want to bind the photo service to an instance that we're specifying in advance. So that that'll get us a long way when we're ready to swap out implementations, right? And then using the handler variable arguments, we're able to get that injected into our particular handlers, right? So you can see these are just coming in as though they were arguments to the closure, but these can be anything, right? Anything that's available and bound in the Ratpack registry that we can get at. So that's pretty cool. This is probably dependency injection done right, I would say as well, because using the Groovy syntax, you never have to think about it, right? You just say, I want a photo service, and Ratpack says, here's the photo service that you said that you were going to give to handlers earlier on, and that's all that you have to do to get there. Okay. So this all starts with handlers. And handlers are an extremely important concept in Ratpack. So how many people here have done traditional like servlet style programming, servlet API style programming? So how many people here have written a web application in the last 5 years? So you've probably done servlet style programming. Perfect. So in servlet programming, there are two things that can effectively talk to the edge, that can interact with a request, filters and servlets, right? So a servlet is sort of a terminal request. That's the endpoint. That's where your work is going to happen to get an appropriate response back to your client. And a filter is some mechanism that you can utilize through the request processing chain to manipulate that request as it's going through the processing, right? So you can chain many filters together in servlet programming. People are familiar with this concept, yeah? How many people have written a filter for a servlet application? Oh, so like everybody. All right, so I don't need to tell you. Got it. In Ratpack, you can think about a handler in that Groovy DSL that we were looking at. You can think about a handler as the essence of both a filter and a servlet. So it can be the endpoint. It can send a response back to the client, and when it does, the request is done processing. Or alternatively, we can jump through many handlers before we get to the endpoint that we actually care about, right? So that's a pretty cool way. Ratpack is capable of doing this because it programmatically chains those handlers together. I'll show you guys what that looks like. This is pretty cool. Whoops. Let's try that again. Whoops. Okay. So now what I've done is I have taken so it's the same application that we just saw, right? Everything is exactly the same. I'm not trying to trick you guys. But the difference is that I've added a handler at the top here. And of course, order matters, right? Because we're chaining things together. Order is very important. I've added a handler at the top here to say, if the user agent is Chrome, then what we want to do is we want to send back a 418 or for the status code savvy in the group, that's I'm a little teapot. Or maybe it's just I'm a teapot. And then we want to send back a response to say, hey, you're not welcome here, Chrome, right? We don't like your kind. And this will be a terminal response, right? Because this is the end. We've sent the response. It's over. There's no more processing that could possibly happen for the client. In the case where it's not Chrome, then we're going to say, OK, you're good to go. You've made it, right? So we're treating this handler like a filter. And we're saying, well, we want you to be able to move on to the next one now. And if the next one matches, we want that to be able to process accordingly. So you can chain sort of an infinite number of these together. So we'll go ahead and fire this thing up. We'll go ahead and shut down the other one first. How about that? So we'll start this thing up. I, of course, am using Chrome like a grown-up. And we'll go ahead and refresh and say, oh, man, this isn't, we're not welcome here. Shucks. But if I pretend for a second that I like Safari, Yay, everything worked fine, right? So we're able to introspect the request as it's going through the chain, make decisions about how the processing flow should work, and then either programmatically inject the chain to say, OK, go on to the next one, or send a response back and say, stop. Part of that development time hot reloading kind of thing that we talked about earlier, developer productivity. If we say, oh man, I didn't mean for this to be Chrome, I meant for this to be, of course, MSIE. You're not welcome here, IE. I don't have IE to prove it, but this has reloaded in the background, and we can refresh it and say, OK, this works now, right? So that's a pretty cool thing that we can do. And this is demonstrating the power that handlers provide to Ratpack applications and kind of what they're all about. So they really are the most important thing. It really is the easiest way to write a composed web application, in my opinion. But so that gives us a lot of flexibility in the routes and the way that requests are handled, and they can be influenced at runtime, which is very important. Because sometimes we'll have routing logic, right? We'll have maybe a customer vendored out. Maybe we'll take our application, we'll vendor it out, and have many clients consuming the same application. But we want it to follow a different route, either based off of configuration or off of some other aspect of the request that we need to introspect at runtime. But it's not just about requests and responses and about routing and handling. Believe it or not, handlers are not just about handling requests and responses. Handlers are actually used throughout the framework for a variety of different purposes. They can be used basically anything from regular closures. The closures that you see in the Groovy DSL in that ratpack.groovy script that are actually handling requests get translated over into a handler. To alternatively, the mechanism that actually starts up the Ratpack application is a handler. So if we look at script-backed app.java, you can see the very first thing that happens in here when we're creating a script-backed app is we're creating a handler, right? And this is what's actually going off and performing the work to get the application stood up and running for us. So handlers are a pretty cool thing. They're also used in the HTTP client for creating the request spec. Is that right?
Sure.
OK, that's sort of right. And for a variety of different purposes. So basically, if you understand handlers in Ratpack, if you guys really thoroughly want to grok the framework, if you understand handlers, you really get everything else. It just makes sense at that point. And it's kind of that. It's kind of speaking to the way that the application gets structured because of its non-blocking nature, right? So you need to have handlers for working. So that's cool. So again, talking about the dependency injection aspects, Ratpack really does dependency injection 100% right. And it's probably the only web framework that does. I'm not biased. But I think that with Ratpack having its abstraction on the dependency injection framework, so Ratpack ships with Juice right out of the gates very recently, and we'll demonstrate it now, or not now, but shortly we'll demonstrate it. We got Spring Boot support from Laurie, put that in for us. So the dependency injection framework that sits underneath how you're getting components into your handlers is totally abstracted away. So that allows us to kind of swap in and swap things out. And that's being handled through this concept of a registry. In Ratpack's sense, the registry is effectively the mechanism by which you should retrieve components instead of maybe in favor of, I would say, going directly to the underlying DI framework. So because we support Juice right out of the gates, we also support Juice modules. You can build very complex and nicely structured modular applications based on that, which Ratpack itself is a modular Juice application effectively. but if you go to the registry, then you're effectively handing that responsibility over to Ratpack to say, resolve this in a way that you know is the right way to do it. And the cool thing about that is that in Groovy, you can simply supply the components that you want, as I showed you guys earlier, as arguments to the closure, as variable arguments, and Ratpack will automatically resolve those from whatever DI framework sits underneath it. And the really super cool thing about the registry is that many DI frameworks can sit underneath it. So you can have this kind of dual state of, on one side you have Spring components coming from a Spring Boot application or Spring Boot configuration under the covers, and then on the other side you can also have Juice doing stuff for you. This is an area we're just beginning to explore practically, and it is really super cool. I'm extremely excited about this kind of stuff. Another really cool thing about the idea of the registry and kind of where this was all born from was the desire to be able to hook up a remote control. So if you guys have ever used Groovy Remote Control library, being able to hook that up to a running application and inject a mock into the registry, so that when handlers resolved a component, it would resolve to the mock. And then when we're done, we disconnect the remote control, and it'll resolve the regular component. Or perhaps more importantly, using the remote control to get a handle on the registry to bootstrap some data for a test, right? A smoke test, something like that. And we can do that all from a functional testing standpoint. And that is only possible because we have a registry in place for doing that. It's a very important kind of thing. So yeah, again, I've already gone over all of this. We have first-class support for Juice right out of the box. Next release will come with first-class support for Spring Boot as well. So you can kind of choose whichever one makes the most amount of sense for you. And again, going down this again, wiring services. This is very simple. So Ratpack itself, like I said, is a modular Juice application. So in some respects, we need to maintain the Juice presence even if we're using Spring today. I'm saying today. In the future, I don't think this will be the case, but Ratpack as a framework will reach into the Juice bindings to pull out certain components that it needs to know about. For example, renderers, right? So one of the things that Ratpack can do, you can just hand it an arbitrary object, and if you've bound a renderer type to in the Juice context, Ratpack will be able to resolve that, and it'll know how to write the object back to the client. So you can make decisions through renderers about, do I serialize to XML, to JSON? Very complex logic for serializing the details there. So I'm going to show you guys a demo real quick. Because this is a Spring 1 conference, I'm going to show you how to do it with Spring Boot. This is all really cool stuff. Like I said, brand new conference-driven development going on here. But it's cool. Sorry? How long until the release with Spring Boot goes in? So we release on the 1st of every month. So it'll be in the next one. So what month are we in? September? So whatever month is after this. That thing. Okay, you're a funny guy. We'll talk about that later. Actually, we'll talk about that very soon. That's a real question. Let me kill this thing off. Okay, so here we have now this is maybe a little bit more complex than it should be or looks to be, but just understand what we're doing here. Like I said, we have first-class support for binding Juice modules. So I've created a Juice module right here. And what I'm doing is I'm binding a listable bean factory, which is a Spring construct, right? Spring's bean factory. Oh, sorry. You guys can't see that. So what I'm doing here is I'm binding a Spring's bean factory that we're able to get back out of this Spring Boot Spring application.run .bean factory. So when you're using Spring Boot's run concept, its static run method, this returns you an application context, right? And then off of the application context, you can get the listable bean factory. Listable bean factory lets us resolve beans as components and we can do that through the registry mechanism, like I talked about. And then I'm also, just for demonstrative purposes, I'm showing you how we can bind a service in Juice, and I'll demonstrate for you guys how we can kind of have that mixed state of resolving some components from Spring, some components from Juice. This is the really hot stuff that's going on right now, and really cool. So we have our handler chain, right? And one of the handlers that we have in here is that as part of the processing chain, we can register an unlimited number of registries, right? And they can be backed by any DI framework. So the very first thing that we're doing, and also again, the dependency injection can happen really at any point in the processing. So I'm injecting the listable bean factory into the handlers block, and then I'm taking that listable bean factory and using this Spring class with the static registry method that comes as part of Ratpack Spring Boot integration to tell it that I want to build a Spring registry and I want to register that. And then from within my handler, a very simple handler, I have Dan's service, which I have not registered in the Juice context. I have Dan's other service, which I have registered in the Juice context. And then I have Dan's app config. We end at 4, right? Yeah? OK. It's like, oh no. And then we have Dan's app config, which is not also coming from Juice, but is rather coming from Spring, and I'll show you what that is. Now, one of the cool things about Spring Boot is that it has really super powerful constructs for externalized configuration, better than any framework I've ever seen. So that's something very much that we want to leverage, I think, probably in any application. So take a look at this real quick. I'm just saying this is a component. This has configuration properties that are being built off of the app key. I have an application properties here where I'm specifying a name, right? And Spring Boot, because of this, will automatically pick this stuff up and create this Java bean for us, right? And it'll put it into that Spring application context that we started up as part of our application, or as part of the application's initialization process, and that now we're able to get a handle on within our handler through the registry, through Ratpack's registry, right? Is everyone following this? Okay, I'll synchronize this, I'll fire it up. So what we should see here is I should be getting a message off of Dan's service. And the cool thing additionally about this is that Spring 4 and Spring Boot start so fast. They add such little overhead to the startup time of a Ratpack app. And you can see it's fired up. This is Ratpack 099. So some of the login messages have been taken away for us. But what we should see here is I have Dan's service, right? And Dan's service has a get message method on it, and that says hello. And then I have Dan's other service, which again, we initialize this in the Juice context, and this says goodbye. And then I have my config that we saw in here, and it says my application. So we should see hello, goodbye, my application, right? And that'll be the example. And voila.
So Dan,
yeah.
is that a Spring Boot app that has Ratpack inside, or is it a Ratpack app that just utilizes Spring Boot?
It's a Ratpack application that's utilizing Spring Boot. Yep. Yep. Yep.
Thinking about handlers as though they are like filters.
Yeah.
Except you're re-registering the registry with the listable bean factory every time you do a request.
Yeah, that's correct. Yep. So registries are bound to a request.
Oh.
Yeah. But the DSL makes it super easy to do.
That means you have an additional registry.
Oh yeah, totally. Yep. Yeah, exactly. I know. It kind of blows your mind, right? Like where do I want to grab these resources from? You can actually put logic around that kind of stuff. Yeah. This is better. This is so much better than just Juice or Spring by itself. If you're going to write a web application with dependency injection, this is the way to do it. And again, I'm not biased. These are I'm speaking as an expert. And I think in the future where we want to get is where renderers can be resolved from anything within the registry, right? From any registry that exists, and we'll get there. We're actually not that far off. But today, renderers, for example, need to come out of the Juice bindings, because that's where Ratpack the framework knows where to look for them. So, so like I said, Spring Boot has really super advanced configuration. That's really cool. So today, next release, whatever, whenever we get the APIs for Spring Boot integration locked down, and we're 100% confident with it, we can leverage Spring Boot's configuration mechanisms within our application by getting a handle on those Java beans through the registries. Now, there are some other places where we need to get configuration, and for that, Ratpack provides the ability to supply a configuration file called ratpack.properties. It must sit next to ratpack.groovy in the structure. And from within there, you can specify anything under the other key and you'll be able to get those off of the launch config object, the launch config component that exists in the Ratpack registry. So I'll show that to you guys. Because this is a pretty good way of getting a handle on any kind of externalized configuration that you need. Okay. Okay. So inside of here, so I'm doing something different here, where basically what I want to do is be able to, I want to be able to take my photo that's getting rendered, and I want to be able to show a different client logo for a different situation, right? So basically, this is kind of the idea of branding your web application. If you guys have multiple clients that you want to provide a style for or something like that, same essential application, right? But you're just putting a different logo, a different header on it. Then within your application, we can have the launch config. We can get a handle on the launch config just as we would any other object from the registry. And we can use that .getOther to get the client. And if nothing is provided, so the contract for this is try to get the client key, whatever that might be. And if you don't have that, then default to this. And what we've done is provided a default, right? So I'm passing this as a parameter off to the Groovy template. So when I'm rendering this, whoops, I don't want to show you that. I want to show you this. When I'm rendering the header for this thing, I want to render out whatever that client logo is, right? So if I go ahead and start this up, you'll see what we should have is we should fall back to default-logo.png, right? So we kind of spiced up the application a little bit now, make it a little bit fancier, and that's exactly what we have, right? I have this Ratpack logo, but now I have a client. I have a really cool client, and they're called Netflix. And so what I want to do is I want to put them into my configuration now and say, Netflix is the client that I want to brand this for. I'm going to change the configuration, which changes the launch config, so we need to restart the application. And once I do that, then it's going to now resolve a different style, right? So it's the same effective application. We've just branded it differently, and that's a pretty powerful example, I think, of using that other capability from the ratpack.properties. You can put anything in there, right? If you have database details that you want to embed in that thing or that you want to pack in that thing, so that instead of writing this stuff out, you can have it come from there, then you can definitely do that. So this is more or less our story right now on externalized configuration. Externalized configuration is very hard to get right. and like I said, Spring Boot, I think, is the only framework that I've seen actually get it right, and they've done a fantastic job of it. It makes a lot of sense with our Spring integration to be able to use that. We're improving this in the core, though. This is a problem that's just beyond any DI framework, right? We can't just rely on the DI framework to hand us back configuration objects. We need to have a standard mechanism and a standard way of doing that. So we have We have a couple of issues open on GitHub right now. If you guys are interested in tracking those are being actively developed and worked out. We have probably daily discussions in the core channel about how we're thinking about tackling these problems. So it's a well-known thing. It's getting better. We'll get better than just Ratpack.properties. Testing is, of course, a first and foremost, it's something that every framework needs to do, right? And it needs to do it very well. All too often, though, frameworks don't do this until after the fact, right? They build up these really great frameworks, and then they say, oh, people are going to write applications with this. They probably want to test them, too. This is not the case with Ratpack. Ratpack started out as we want people to be able to test very thoroughly their applications and to do it in a smart and pragmatic kind of way. So testing is a breeze in Ratpack. Functional testing, because of the sub-second startup times, functional testings of your applications are very simple to do, right? Ratpack provides fixtures for local script application under test, and test HTTP client, really making functional testing a first-class citizen. Amazing, just the best integration with Spock. No extensions, it's all just native stuff using Groovy and Spock. Makes everything very easy to do. There's some really great examples. One that I want to show to you guys is this one in particular. So under the Ratpack org on GitHub is this example books project that Russ Hart put together. And this basically showcases all of the features offered by Ratpack. And one of those features in particular is testing. So he has this pretty well understood and very well grokked. So an example of using the test HTTP client, using the remote control plugin. I'll demo the remote control plugin as well because I think that that's a very important one to understand. So you can stand up a local application script under test, and then all of your specs can be designed around those functional capabilities, right? So he's making requests into his application that's up and running in this context to perform some operations here, and then he's able to assert that things have happened properly, right? So you'll find very good test fixtures if testing is important to you. Show of hands, is testing important to anyone? Good, you're all still awake. Cool. So that's a really great resource, example books under the Ratpack organization on GitHub. Another thing, oh, that came out really well, didn't it? Yeah, weird. Whoops. Let's try that again. Yeah, here we go. So another thing that we have, so that we talked about this earlier, the framework is composable. You can use aspects of the framework in different contexts. A really big one of those is its testing fixtures. So if you guys have a regular application that's not Ratpack, and you need to get access to some external resource like an API or something like that, you can utilize Ratpack's embedded application ability to stand up a mock HTTP server that your functional test will be able to hit. And then you can assert details about did call X do Y, right? So that's a pretty cool thing. This can be used to basically test anything, which is a really neat thing about it. And it comes with a fluent DSL that you can embed into really any testing framework. It seems to fit nicely into Spock because of Groovy. I'll demo that for you guys right now. So we have our project here. And before we didn't have any tests. That was a no-no. Now we have some tests. This is really cool, right? So what we have here is I'm making use of this, of the embedded application construct that comes with the Ratpack's testing fixtures. And I'm saying I want to stand up a whole new embedded application with this structure, right? And I'm doing this just so that I can test the one thing. that one photo service implementation in particular. And then I can use the fantastic test HTTP client that comes along for the ride, which has since been updated to an even more fantastic one, to assert some detail about my interaction with that module, right? So I don't need to actually fire up my local application, local script application, in order to be able to utilize Ratpack as a testing infrastructure. So I can run this as a JUnit test, of course. It's a Spock test. And my tests always pass. Don't worry about that. But yeah, you can see that this actually went ahead. We fired it up. We bind it to a random port, so you don't have to think about that, right? And what you get back out of this is an actual object that you can work with, and you can just send this to the test HTTP client to perform the operations that you need to, right? So this returns an object for you to work with. Luke says that this is one of the most important parts of the framework, and I believe him, because it's I've never seen another web framework that emphasizes being able to test your application, not our stuff, your stuff, so heavily, and really understanding how you would go about doing that and making sure that the right fixtures are in place for that. Again, we can make use of the remote control, Groovy Remote Control library to influence some state of an application under test. So basically, we can bind this by providing a launch configuration detail within our test to a local script application under test, and then we can reach into the registry, manipulate the data, and then send a request off to go and do something. Has anybody here used this in Grails? There's a remote control plugin for Grails that'll let you do the same thing. Yep. So Laurie's used it. Okay, I'll show this to you guys. So before, all I had was the photo module spec where I was working with an embedded application. Now I've added a functional spec, and this is actually going to start up that local script application under test, and we're using that other key. We can supply a map to starting up local application script under test, which will set these launch configuration properties. If we send this remote control enabled equal to true into there, it'll guess what? It'll turn on the remote control. So then we can use it, and we get a handle on the remote control by just creating a new remote control object, which comes from Ratpack's remote control testing fixtures, and we can attach the script onto there. And if we run this, so effectively what we're doing here is we're getting a handle on some aspect of the registry. In this case, it's a PhotoDB object, so things have changed a little bit, and we want to save something and do that so that when I make a request, I know that I have data bootstrapped, right? And then I want to write back some details, right? So we started up the Ratpack app, we injected the data, so we bootstrapped some test data, and then we made the request. And this is all going through our regular Ratpack application at this point, right? We're not standing up a new embedded application. We're actually firing up the one that we are working with and performing a functional test. And again, that goes back to the value of the registry, right? That we're able to reach into the registry and make those manipulations through the remote control plugin. We don't have to worry about any bindings of any underlying DI to be able to get a handle on those details. Okay, so once you have your applications built and up and running, we'll probably fly through the rest of this so that you guys have some time for questions or anything. One of the things that's important to note about Ratpack is very unique as a web framework in that it tools the build system. So it ships with the cool thing about having the creator, or at least the most contributive member of the framework work for Gradleware, is that we get a great Gradle plugin out out of out of the whole thing. So we have excellent integration with Gradle, which is fantastic, and we can build a distribution, a tarball or a zip, and we can ship that, and that ships using the app. It distributes, it packages itself using the application plugin in Gradle, and it'll give you basically a bash script to get up and running, which is really neat. Or you can use FatJar, which will create a runnable jar file distribution for you, and you can get up and running that way. This comes for free, right? You don't need to do anything special. There's no additional configuration that needs to go into your build config to get this stuff. So beyond the basics, recently added support for HTTP streaming. We have implementations of reactive streams. Is anyone familiar with the reactive streams manifesto and the ideas behind that? Reactive programming going on in reactive programming fits very well into an asynchronous, non-blocking programming model. It's something that we utilize very heavily. So streaming support basically, I wanted to spend a little more time on this, but the assertion that I'll make for you guys and let you ponder it a little bit and reach out to me with criticisms if you feel like it, is that all modern applications should be using HTTP streaming for sending data back to clients. There's this old paradigm of request response. This is done. We don't need this anymore, right? So streaming support is very good. Very good. It's new. It's evolving. It's pretty cool stuff. There's no good reason, like I said, to reestablish a new connection for every request, and basically everybody can benefit from this. The old way of programming web applications, I think, is out the door. So it's great that we're kind of ahead of the curve on this, I think. We also have support for integrating our reactive streams API with Reactor, Project Reactor, and RxJava. So we can basically use them as publishers and subscribers. They're conforming to the reactive streams API soon, if not already, which is pretty cool. And a big tenet of HTTP streaming is this idea of back pressure. And back pressure basically assures that you're not going to overwhelm a client by sending too much data to it at any given time. So the concept behind back pressure in reactive programming is kind of probably one of the most important things that your libraries are able to do, and we're capable of doing that. So a client will instead come to us and say, I'm capable of consuming X amount of data, and we'll ensure that publishers can only send X amount of data to that client, which is really neat. So you can have publishers internally to your Ratpack application that are scheduling responses to go to a client periodically on a loop or something like that. And then when the client requests it, they might say, hey, I can only handle one message right now. I'm under a little bit of load. So we'll only send one message on behalf of that publisher. So this is really neat stuff. So we've got this kind of stuff down. Getting back to that idea that we're a full stack web framework, we have integration with some of the best of breed in the ecosystem. For authentication, we're using Pack4j. We have handlebars and Timeleaf integration for server-side templating. For request caching, we're using Hystrix, which is a Netflix open source project. Reactive programming, like I said, RxJava and Reactor, and also making use of the reactive streams APIs to get there. For monitoring and metrics, this is also a very important thing. We have integration with New Relic and support for broadcasting code-to-hail metrics. So if you include the Ratpack metrics module in your project, then you get a dashboard for free that gets that a WebSocket broadcast will occur to update that detail for you. So you can look at how your application is performing, and you don't have to do anything to make that happen. And also session support with Ratpack Session. So all the implementations and all the demos that I've kind of shown you guys today have been just stateless things, really easy, back and forth request response type stuff. In reality, you will probably need to make use of a session at some point, and we have a module for doing that. And of course, because of the modular nature and the ability to compose the framework, this is growing by the day. And like I said, we just integrated, or we're in the process of integrating Spring Boot. So that's pretty cool stuff. Roadmap, Craig, you asked earlier, when's the 1.0 release? So our plan right now, we release on the 1st of every month a new version. So you get all of the cool production-ready features of the last, since the last release, basically, that have gone out. Before we go 1.0, we need to, we're going to move the APIs to Java 8. All the internal APIs will be moved to Java 8. There's a lot of reasons to do this, not the least of which is that performance will be so much better, which is crazy because performance is already really awesome. But yeah, so we need to move to Java 8 first. We're limited by moving to Java 8, believe it or not, because Heroku doesn't support it yet, and we run our website on Heroku. So we can't move just yet, but we're getting there. No 1.0 release. This is a directive from Luke Daly. He's the project master. No 1.0 release until the APIs are fully locked down and until we have very thorough documentation. So like I said, the in-code documentation is great. Everything is tested very well. Excellent examples to build off of. The user manual is essentially non-existent. I shouldn't say that. A lot of people have put a lot of hard work into building the user manual. It's limited, though. It's lacking. So we need to grow these things up a little bit, right? And we need to get it to the point where we're ready to move to Java 8. The ecosystem is ready to move with us, and you won't see a 1.0 until then. But in the meanwhile, Ratpack is not incubating anymore. We have over 50 worldwide contributors with over 2,500 commits. I just looked yesterday. I think we were at close to 2,700 commits on the project. The API can be feature locked now. So for a very long time, we were running in 09 snapshot mode. Now we're in the 9th month now. At the beginning of next month, we will release 0.99. So this entire year, we've been releasing stable version locked releases, which is really cool. So if you want to begin adopting this, you don't have to worry about the APIs necessarily changing underneath you for a particular application. They might change version to version, but if you lock it to a particular version, you can definitely use it and start to adopt it. We of course have a growing community. This is amazing. I think a year ago the turnout was like maybe 4 or 5 for one of these talks, and I had a great turnout at UberConf. This is a very good turnout. I'm happy to see all you guys involved with this. I'm really glad you guys are all excited about it. And if you're interested in contributing back, the best way is to use it. So we also have a forum, forums.ratpack.io, that you can go onto and you can ask questions. Everybody from the core team will answer your questions. If you guys don't know how to do something or it's not documented enough, that will give us impetus to get stuff really moving in the right direction. The fact that Grails 3 will have an application profile for Ratpack is going to be huge for us, because we'll have I think a broader group to adopt Ratpack, and we're looking forward to that. You can help improve the user manual. So if you go through and you figure out how to do something and you had trouble with it because it was undocumented, you can then kick that back to us. Or even, like I said, get on the forum and tell us, hey, this was undocumented. This is how I figured it out. One of us will jump on it and do it. And we always need really smart people to help take us to the next level. We just brought on Danny Hyun, who is just a fantastic contributor. He's awesome. We have a growing core team. Everybody is very engaged. It's really becoming a very extremely serious project. It would be great to get more people involved with it and to have people help grow the community, stuff like that. And last but certainly not least, this is the core team. Make sure that you follow us all on Twitter, as well as Ratpack Web Framework, Ratpack Web on Twitter, at Ratpack Web. I'm not sure what it's called. But it's me, Luke, Russ, David Carr, Jeff Beck, who's up at the front here, Rob Fletcher, Marcin, who does Jeb, and Danny Hyun, like I said. So get in touch with us if you guys have any questions. Peter.
Why do you get typeface ahead of Luke today?
Why do I?
Yeah.
Oh, well, because Luke's not here. That's why. Yeah. Sorry, Luke. Questions? Yeah.
One of the things I've been really interested in async frameworks is, can you implement a timing filter as can you show us how to do that and make one of the handlers?
To,
Request comes in, there's a bunch of asynchronous stuff going on, but at the end of the day, I want to know how long the whole thing took end to end.
yeah. Yes.
That's one of the things that I just
Yes.
Promises. You should.
I can show you. Let's follow up after this. I'll have to think through it a little bit,
Okay.
because state, of course.
Exactly.
Yeah. But this has been done. We've clocked this. I think actually Russ has an example of doing this.
Okay.
Any other questions here? Comments, concerns, snide remarks? Yeah. Yeah.
Is Java 7 really a possibility? Like you showed all this Groovy stuff.
Yep. Yeah, you can use as many anonymous inner classes as you want. That's what it comes down to. Yep. Much better support for Groovy in Java 8. I'd be scared of actually, since you mention it, if you're super interested, somebody just recently asked me about this. Java 7 Ratpack example on my GitHub. It's gnarly, man. Rat. Oh, sorry. Actually, we're doing it in Java, so we don't have a ratpack.groovy. You create a binding spec, you attach it to some chain action, and then you apply handlers. So we only have one here, and we're at 35 lines of code. You can imagine where this is going. If you have, maybe you have 10 routes or 15 routes, right? It gets into something much different. But yeah, there are definite constructs for being able to put this stuff in actual, class structures. You don't need to use the Groovy DSL. Yeah, totally possibility. Anyone else? All right, folks. Thanks a lot for coming.